right, so we're in section 8.3 today. So we kind of we went ahead a little bit on Friday. So we're going to talk about inverses of matrices today. So what our motivation for talking about inverses is, guys, listen up. Our motivation for talking about inverses of matrices is we want to be able to write a matrix equation and solve it like we do an algebra equation. So if we have an algebra equation, a times x equals b, to solve for x, we divide by a, and we say x equals b divided by a. Well, in terms of arithmetic, dividing by a is the same as multiplying by the inverse. We multiplied by the inverse of a on both sides. We want to be able to solve a matrix equation like that. In order to do that, we need to talk about an inverse. We can't just divide by a matrix. We don't. That's not really something that that's really defined. We know how to multiply by a matrix, but dividing by a matrix is the same as multiplying by the inverse. So that's where we're going with finding inverses of matrices. So a couple of things about matrix inverses. We can only find the inverse of a square matrix. So just like a determinant, we can only find the inverse of a square matrix. So we have to have a 2 by 2, a 3 by 3, 4 by 4, something like that. Any other kind of matrix, we can't. There's the idea of an inverse doesn't really exist. And we're going to define the inverse. So if we have matrix A, the inverse we write a to the minus 1. And the inverse of matrix A means that if we multiply A times its inverse, it's the same as multiplying the inverse times A. When we multiply a matrix by its inverse, we get the identity matrix. And just as a reminder, I is the identity matrix. And the identity matrix has ones on the diagonal and zeros everywhere else. So we talked about the identity matrix right at the beginning. So a couple of examples of identity matrices. So that would be a 2 by 2 identity matrix, a 3 by 3 identity matrix, and so on. So we have ones on the main diagonal and zeros everywhere else. So if we multiply a matrix by its inverse, or if we multiply the inverse by the matrix, we get the identity matrix. That's how we know that our matrix is an inverse. So questions on what an inverse matrix is. So we can think of this as kind of like multiplying. If we multiply 2 by 1/2, we get 1. If we multiply 4 by 1/4, we get 1. It's the same kind of idea. So a question you might get asked about the identity or about inverse matrices would be something like this. We want to show that B is the inverse of A, where A equals a 2 by 2 matrix, negative 5, 6, negative 1, 1, and B is a 2 by 2 matrix, 1, negative 6, 1, negative 5. So to show that a matrix is the inverse of another matrix, we multiply them and show that we get the identity matrix. So we're going to multiply negative 5, 6, negative 1, 1 times 1, negative 6, 1, negative 5. And this will be good because we can review how we multiply a 2 by 2 matrix by hand. So if we're going to multiply this, we're going to multiply the rows in the first matrix by the columns in the second matrix. So the first row, first column, I get negative 5 times 1 plus 6 times 1. First row, second column. I'm going to multiply the first row times the second column. I get negative 5 times negative 6 plus 6 times negative 5. Now I'm going to go second row, first column. Negative 1 times 1 plus 1 times 1. Second row, second column. Negative 1 times negative 6 and 1 times negative 5. And when I simplify this, I get negative 5 plus 6 is 1. I get a positive 30 minus 30, so I get a 0 there. Negative 1 plus 1 is 0 there. And negative, did I multiply something wrong here? First row, negative 1 times 6 is 6, plus negative 5 is 1. There we go. So I multiply these two matrices, and I get the identity matrix. And then I would also need to do it in the other direction. I would multiply 1, negative 6, 1, negative 5, times negative 5, 6, negative 1, 1. I'm not going to go through the process of multiplying those, but that comes up to 1, 0, 0, 1 also. So to show that a matrix is the inverse of another matrix, we multiply them and show that we end up with the identity matrix. Now before I move on, any questions on how I multiply these? So again, on the quiz, on the test, the vast majority of the problems are going to be without the calculator, so you're going to need to know how to multiply a 2 by 2 matrix by a 2 by 2 matrix by hand. So you need to be able to do that process without a calculator. All right, so that's how we show the two matrices are inverses of each other. We multiply them together, either direction, we get the identity matrix. Well, our next problem is going to be, how do we find an identity matrix? So how do we figure out what the identity matrix of a particular matrix is? Well, there's a hard way and there's an easy way. I'll show you where the process comes from, and then we're just going to do the easy way. So I'm going to say how we find inverses. So if we have some matrix, I'm going to show you where the process comes from, and then we're just going to do the easy way. So if we have some matrix, say A equals 4, 5, 7, 9, For a matrix to be the inverse, we have to find some matrix, and I'm just going to call it A, B, C, D. That has to give us the identity matrix. So when I multiply this out, I have to get 1, 0, 0, 1. I have to get this identity matrix. Well, if I multiply this out, I end up with a bunch of equations. If I go through the process of multiplying, I end up with 4 equations. So when I multiply this out, if I go through the process of the multiplication here, I would get 4a plus 5c equals 1, and 7a plus 9c equals 0. So that would come from the first row, first column, and second row, first column. So I'm just multiplying these out. And then when I do the first row times the second column, and the second row times the second column, I get 2 other equations. I get 4b plus 5d equals 0, and 7b plus 9d equals 0. And that comes from the second row, and the first row, second column, second row, second column. So to find the inverse, I can solve both of these sets of 2 equations to find A, B, C, and D. Well, that is a lot of work. Thankfully, there's a shortcut. For a 2 by 2 matrix, and this shortcut works for a 2 by 2 matrix only. So the process comes from this. So we're going to use this shortcut. So our shortcut for a 2 by 2 matrix only is, it has to do with the determinant. If our matrix is some matrix A, B, C, D, and the determinant of A is not 0. So our determinant can't be 0. Remember, these straight bars mean the determinant. The inverse of A is 1 divided by the determinant of A, which we know how to find, which is easy to find, times this matrix that I just rearrange. D, negative B, negative C, A. So all I'm doing to the matrix here is switching A and D and changing the signs on B and C. So for a 2 by 2 matrix, if the determinant equals 0, this quantity is going to give me the inverse. So we know how to find the determinant, and then we just rearrange the elements in our matrix and we have our inverse. For a 3 by 3 or bigger, we're going to use our calculator to find the inverse. And we'll do that in just a minute. So any questions on what we're doing here to find our inverse? So for a 2 by 2 matrix, I have this nice little trick. So let's look at an example of using this. We want to find the inverse of three, 2, 9, 5. So the first thing we need is the determinant. So how do we find the determinant of this matrix? Who can help us out here? 3 times 5? And what's next? Minus. To find our determinant, we multiply these two and subtract multiply these two, 9 times 2. So I get 15 minus 18, you get minus 3. So our inverse, so a minus 1, is going to be minus 1/3 times, I'm going to switch these two and change the sign on these two. 5, negative 2, negative 9, and 3. And that's all there is to finding the inverse of a 2 by 2 matrix. Swap these two, change the sign on these two, and multiply by 1 over the determinant. Questions on that process? All right. So this is the process that we're going to use to find the inverse of a 2 by 2 matrix. Swap these two, change the sign on these two, divide by the determinant. As long as the determinant's not 0, I can find an inverse. For a 3 by 3 or bigger, we're going to use our calculator. So let me just show you one example of finding the determinant of a 3 by 3 with your calculator, just to remind you how to do it with your calculator. So there's my calculator. I'm going to go into my matrix menu, and I'm going to edit matrix A. So I'm going to enter in a 3 by 3 matrix. There we go. So I'm going to do the matrix 1, 2, 5 is my first row. My second row is going to be 3, 7, and 14. And my third row is going to be negative 1, 4, and negative 3. So there's my 3 by 3 matrix. I'm going to quit out of there. And to find the inverse, I'm going to get matrix A here. And I'm going to use the minus 1 button. And there's my inverse. And we have some big decimals here, so we have to scroll over to see everything. Right here. So I just got my matrix, hit that minus 1 button, and the calculator tells me the inverse. Now if your calculator tells you singular matrix or something like that, that means the determinant of your matrix is 0 and it doesn't have an inverse. So a 3 by 3 matrix, if the determinant of a 3 by 3 matrix is 0, just like for a 2 by 2, it doesn't have an inverse. So if you put one in your calculator and it can't find the inverse, it'll say singular matrix. So questions on how we do this with our calculators? Enter our matrix just like before, and we use the x to the minus 1 button. All right. So what we want to do with inverses, we said at the beginning, is we want to use inverses to solve matrix equations. So let's look at an example of how we're going to use inverses to solve matrix equations. So the kind of equations that we're going to solve here is if we have some matrix equation, so we're going to say A, B, and X are matrices. We have a matrix equation A, X equals B. The solution if A has an inverse, X equals A minus 1 times B. So essentially what we're doing is multiplying both sides by the inverse of A, and that lets us solve for X. So if we have a matrix equation that's set up like this, our solution if A has an inverse is the inverse of A times B. So an example of this is we have this system of equations. 2x minus 5y equals 8. 3x minus 8y equals 1. We want to write this as a matrix equation and then use inverses to solve this. So first off, let's rewrite this as a matrix equation. So what's going to be my coefficient matrix here? What are we gonna get here for our coefficient matrix, Kenny?
2, -5, 8, dot dots.
Okay.
3, -8, 1.
And I'm just going to write it this way, and this is going to equal 3, -8. There we go. And this is going to equal 8, 1. So I'm not writing the augmented matrix. So this is my coefficient matrix. You got the coefficients right. And we're going to multiply this by xy. So if I multiply this matrix times this matrix, I end up with this system of equations. So there's my matrix equation. So this is A, this is X, and this is B. So A times X equals B. Our solution, X is going to equal A inverse times B. So our first step here is going to be to find the inverse of A. So I need to find the inverse of A. Well, we have a 2 by 2 matrix. So the inverse of A is going to be 1 divided by the determinant times our coefficients rearranged. So let's find the determinant of A. The determinant of A is going to be, how do we find the determinant of this matrix? Can you help us out, Devin? 2 times -8 plus, sorry, it'd be minus 3 times -5. So I get minus 16 plus 15 is -1. So the determinant is -1. And then we're going to rearrange these. I'm going to switch these two, change the sign on these two. So the inverse of A is 1 over negative 1, so I'm just multiplying by negative 1, times negative 8, 5, negative 3, 2. And when I multiply this by negative 1, my inverse is 8, negative 5, 3, negative 2. So there's my inverse, and I'm going to multiply that by b. So x equals 8, negative 5, 3, negative 2, times 8, 1. And I get first row, first column, I get 8 times 8. Minus 5 times 1. And second row, first column, I get 3 times 8 minus 2 times 1. And when I add those up, I get 8 times 8 is 64, minus 5 is 59, and 3 times 8 is 24, minus 2 is 22. So my solution would be x equals 59 and y equals 22. So I found the inverse of a, multiplied it by b, and that gave me my solution. If you're doing a problem like this and you come up with a determinant of 0, then your system is going to have no solution. You have to be able to find the determinant to come up with a solution. Now if we had a 3 by 3 system, we would do it the same way. We would just find the inverse of the 3 by 3 matrix in our calculator and multiply it by the 3 by 1 matrix using our calculator. So for a 2 by 2 system, we can find the inverse by hand and we can multiply by hand. Questions on that process? So our two important ideas here are, one, the inverse, what the inverse does. We multiply a matrix by its inverse, we get the identity matrix, and we can do that in either order. And we have a process for finding the inverse of a 2 by 2 matrix that involves a determinant. And two, we can use the inverses to solve systems of equations by rewriting them as matrix equations. All right, questions? Okay. Homework, page 579. All right, there you go.